Welcome to today's webinar, Harnessing Operational Excellence, Advanced Imaging and Measurement for Quality Control and Inspection with PRECiV Software, sponsored by Evident. I'm Dirk Ducharme, Editor-in-Chief for Quality Digest and your host for today's webinar. Today, we're going to take an in-depth look at PRECiV analytical software, which now enables seamless control of Evident's advanced DSX-1000 digital microscope. We're going to review the system's imaging capabilities and intuitive controls with an emphasis on showing how you can maximize the software's capabilities for precise material evaluation. PRECiV software enables advanced analyses, including grain analysis, and unlocks a suite of specialized features tailored for semiconductor sample imaging through its innovative Wafer Navigator solution. But before we get started, just a reminder that you can send us questions using the Q&A box. You can find the Q&A button in the bar at the bottom of your screen. If you just mouse down there, you should see it. Send your questions to us as you think of them, and we will answer them after the presentation. A recording of this webinar will be available one day after the webinar, about 24 hours from now. You'll get an email with that information from Quality Digest. And for those of you who need a certificate of attendance, you must answer one of the polling questions that is presented during the webinar. Okay, let's get started. Today's presenter is Rob Bellinger, Product Applications Manager for Industrial Microscopes at Evident, formerly known as Olympus for you old-timers out there. Rob brings more than 19 years of expertise to his role as Product Applications Manager. With a strong dedication to supporting Evident's industrial microscope systems, he provides invaluable applications assistance across the United States, Canada, and Latin America. Okay, Rob, go ahead.
Hi, thanks, and good morning and afternoon to everybody. Today, I have a quick presentation to go through, and then I do have a lot of remote demonstration on an actual live instrument here. So, get started. Thank you, Dirk, for the introduction. Harnessing Operational Excellence, the name of the webinar here. I'll be talking about some of the advanced imaging techniques and measurements for quality control and inspections with our latest software named PRECiV. So PRECiV is a unified software for all of our industrial microscopes, everything from your stereo microscopes, semiconductor microscopes, metallurgical, upright, compound, and inverted microscopes, and even our fully digital microscope. So PRECiV is aimed at improving efficiency without compromises. It's one interface for both our digital and conventional microscope line and all of the accessories associated with it, things like motorized stage options and such. So what we're trying to do is make one simplified user interface across our entire line of microscopes, which now encompass our digital microscope, the DSX-1000. So I'll do a quick review of some of its capabilities, controls, and features within PRECiV, things I'd like to touch on today while we show it off. So PRECiV will allow you to extend your microscope capabilities. It's software user interface is simple to use. You can take advantage of a lot of powerful tools with very minimalized training. Buttons and interfaces change as the operator works through it, so it's very simple and user intuitive of what you have to select or do to get, results of measurements or imaging acquisitions you'd like to take. Again, full control over conventional microscopes. Software works seamlessly with any of our manual or semi-motorized conventional microscope systems, as well as our cameras and accessories, enabling you to capture images in a range of conditions, including, I'll show off today some of those conditions: bright field, dark field, DIC, anti-halation, and such. Again, PRECiV software now controls our DSX-1000 digital microscope, offering 2D and 3D measurements, and integrates all of our material solutions. So I'll be covering a few of those in the presentation today. The analytical software PRECiV has a host of different dedicated material solutions for different advanced analysis or grains analysis and inclusions and steel analysis and things like that. When you connect the system to a semi-automated microscope, including motorized third-party staging systems for X, Y, and focus Z devices, we can automate all that motorization with the PRECiV software. It has a suite of functions for stage control, the ability to create points and alignments, the ability to do image stitching, and not just X, Y, but X, Y, and Z for focus as well. It has a suite of advanced measurements and advanced measurement tools that enable precise, repetitive two-dimensional measurements, doing complex image analysis. It even can have the add-in feature for complex analysis using our true AI or deep learning technology for measuring and detection of very hard to identify particles, patterns, or structures. And again, PRECiV is optimized for industrial applications. We have optional material solutions. You can take advantage of dedicated workflows. The material solutions guide operators through image acquisition if necessary, the measurement routines, loading predefined settings, so we can get repetitive measurements even between operators in all of the dedicated material solutions. So today, I'll do some live overview in the PRECiV software on our DSX 1000. I'd like to show some of the imaging controls and techniques through the PRECiV software. And I'll cover some of the basic measurements and 3D profile measurements using the DSX 1000 to capture the 3D image. I can now put up line profile and show the height measurements as well. I'm going to discuss some of the material solutions and show one of those off. That'll be grains analysis. I have a pre-captured image with grain boundaries, and I'll show how it is to work through one of the material solution modules. And the added capabilities with PRECiV using custom solutions. We get a lot of times requirements for standards that we don't have in the basic solutions. So we have a dedicated custom software development team that makes a lot of custom interface solutions to our software. One of those solutions that we offer and can customize quite easily is navigate on wafer. So I'm going to actually place a wafer I have on and show some of the capabilities of navigate on a wafer through one of our custom solution modules. So on to the live demonstration. My slideshow here. I have the PRECiV software running. And currently have a live image on the screen. This is the standard user interface as the software opens. It has a majority of the screen dedicated to the either live image or captured images. It has a simplified workflow and what we call a vertical workflow bar here, starting at the top, working through your observation. Under observation, these side windows will change based on the workflow buttons that I go through here, the different steps I'll take. It might be observations, some advanced acquisitions, processing of the image, applying filters or changing the image from color to grayscale, placing annotations, going right to 2D measurements, 3D measurements, and then where we house all of our material solutions. So I'll kind of hit some of these points. We also have the ability to create and export out report templates. So I'll move the stage around here. This is a live image. I just have a quick cross-section sampled here that's got some polishing effects on it. I thought it showed quite nicely to show some of the basic observation modes. When you're using PRECiV with a connected microscope, like our Olympus DSX 1000, we can easily switch between observation modes with the control in the software. The system has bright field, which is what we're currently looking at. We also can do oblique imaging. This is where it has the ability to bring lighting in from different angles on the side of the microscope objective. and wait for it to catch up to me. With oblique lighting, we can change from left or right side to create shadowed effects. Maybe it's difficult to see certain effects on the surface, so you can enhance those effects. We also have the ability to switch to dark field imaging. Dark field imaging brings light at high angles to the surface, providing high contrast, bringing out surface structures, scratches, materials, and things like that. So here's our dark field lighting. And you can see a lot of contrast on the surface and edge enhancements. One of the neat things that we have is the ability to do directional dark field lighting. Directional dark field lighting allows us to turn on very small segments of lighting at different angles in the dark field range. And by selecting this, you can see that I can turn on a specific quadrant, and then I can even use the software to rotate the lighting around at different angles. This is useful if you have something with structure that you want to bring out some contrast on and see a lot of the details at one angle of light. The software will let you take a snapshot down here at the bottom at any time. And then there's some advanced tools in here as well, where we can actually show more functions and maybe capture the images at all the different angles of light. That's a case you want to do. One thing that when you're using the proprietary mixed illumination, this is available on a lot of the Olympus frames, like our BX or GX upright compound microscopes, using a mix slider. The digital microscope also has this built in for mixed illumination. What this allows us to do is turn on both the bright field lighting and the directional dark field lighting at the same time. So this gives us a lot of benefit to adding extra contrast on the surface while still seeing the reflected light color surface image. A little bit different than your bright field illumination that gives you just the surface detail, but none of the dark field contrast. We can now select to use mix, where it'll set up both bright field and dark field at the same time. And that gives us that high contrast and surface detailed information. Wait for that to come back up. Seem to have some delay with the mix here. Here we go.
Yeah, the screen sharing with Zoom sometimes slows down video operations, which is why you're sometimes seeing a delay there, just so people know. It's kind of a annoyance of Zoom.
Yeah, it was interesting. So now we're back up with the mixed illumination, high contrast. We also have the ability with a lot of our microscopes to use Nomarski DIC, differential interference contrasting mode. The digital microscope has this built in, and it sets it up for us to show a high contrast surface image. This is actually creating surface texture and bending the light path just enough that you can see even rainbow patterns on anomalies on the surface, low points and high points, a little bit of mist polishing here in the corner. As you see with this rainbow effect, you can see that it actually has a buildup of material here at this edge. So it's kind of nice to show this on the software. So PRECiV interfaces a lot with a lot of the connected microscopes, but again, these observation modes don't have to be automated. If you have a complete manual microscope, you can still set up your observation modes where the software will at least put on the proper intensity values for your exposure. It will, on a complete manual microscope, still set up something called shading correction for the different observation modes. You might need different intensities of pixels across the field of view for bright field compared to dark field, if your manual microscope is set up that way. The rest of the information through here is, some of the controls. If you have connection, again, the control of lighting and light intensities in the software. The control of your camera is always here. We can do full automatic exposure or switch to manual exposure. You can even define specific ranges and regions that you want the automatic exposure to work in. And then the software has, depending on the camera attachment, some ability to do contrast enhancements. And on the digital microscope, we can increase our depth of focus with controls here. Under the image settings window, click on it here, give it a second. There are some more detailed advanced image settings that the software will have and the users have access to. One of those is like high dynamic range imaging. We have the ability to use HDR function in the software to capture, here we go, live HDR with some of our cameras. And high dynamic range is where we can capture multiple images at different exposure times to balance out the contrast. You can also quickly switch your camera. Almost all of our camera modes are capable to do color or monochrome selections down here. You can change the aspect ratio of your camera if needed. So that's some of the basic observation settings and controls of the hardware. I'm going to go through, if I can get it to come back here, the delay, and show the image acquisition on a different sample, doing some 3D imaging with the digital microscope. I'll wait for it to come back. Here we go. Switch back into mix. So I'm going to use my joystick here and drive over to a different part of the sample, a little different sample that I have. I have a little circuit board here with some relief, some height information here. With the difference in height, you can usually change your focus to, pinpoint on what you want. But if you wanted to see all this in focus, it requires, a buildup of the image. Now, there's two ways to do this with the PRECiV software. If you have a motorized microscope like we have here with our digital microscope, it's as simple as going to your bottom of focus and hitting a button for 3D acquisition. If you have a complete manual microscope, we can use a function in acquisition called instant EFI. And instant EFI would continuously capture images as the operator changes focus manually, building an all-in-focused image for them, or we call it extended focal image. But as I said, this system has the motorized system for its focus. So all I have to do is make sure I'm somewhere near the bottom of focus if I need to be, and hit the 3D acquisition or the start button. And the system's going to scan through and capture those three-dimensional height and three-dimensional image. So when it's done, it's going to render an all-in-focused image for us here that I can now switch to a surface view in the software. And I can manipulate this around. I can even do full screen in any point. Even on our live images, there's a shortcut key on the keyboard, F11, to do full screen view. So an operator can see a little broader range of view, manipulate this image around with the mouse. Our 3D imaging here can be saved out as a picture at any angle or any texture you want. We can also, when you right click, it brings up a host of different solutions or settings, like our color surface settings. I can blend things like a lookup table. If you wanted to see the height information here, if you have a motorized focus like I did here, it captured all the height points as well. So based on the intensity of where it came into focus, we can see high and low points with a color mapping. This color mapping is an overlay shadow, so we still see the surface texture. Unlike if you did just the source layer, it would show you just the height data alone. But by applying the texture layer with the blend of a lookup table, we can still see the surface texture in the background and all the color data for height, which is kind of nice. I can always switch right back to my single frame of view. I can exit my full screen. The user might process this image. They might add annotations. It's as simple as clicking in here and putting text boxes and things like that. But they might want to jump right into measurements. Notice as I click into measurements, some of my windows change here at the bottom, showing the measurement results. And I definitely have a whole host of different measurements here. The PRECiV software I'm using on the PRECiV for DSX has the advanced measurement tools. So we have things like detect edges capabilities. So if I wanted to select this and select an arbitrary line measurement, I could come out, select detect edges. I could come out and have it automatically detect an edge here based on the contrast. As long as it falls, the contrast of the edge falls within that circle that you see there, a red circle, the user can just click anywhere near that edge. It will automatically mark it based on the contrast, and then they can move to the other side here, and they can mark the other edge Again, it's using contrast-based marking. It works really well for finding your edge. Once they place the point, it'll show the distance measurements. Okay. They can also do things for 3D. Since I captured this image with height data, I have the ability to put line profiles on my image. I can place a line profile across this point here, and then I can come over to do 3D profile line measurements. So I could select this profile and take, say I want to measure from the base here up to the top of this little component on the circuit board. It'll mark this point on the profile line for us, and it'll show the height data. Okay. Now that you have all these measurement results, like an arbitrary length and a height information, what do you do with this data? You can now save the image out real quick with the save button down here. It'll allow you to save as multiple different file format types, save the images out. We could also have turned on autosave features in the software. So after captured, it could have autosave to a specific location on your local PC or network drive. But the measurements themselves, we can create a workbook internally in the software here, where we can have a workbook that can then be exported to Excel. Benefit of doing it internally with a workbook is sometimes you can sort measurements or filter them how you want before you send it to Excel. Or you can just drop it right to Excel with the button here. If you want to take these two measurements we took, this would just open an Excel sheet, save it out for you. You can also just save the raw data measurement points out to a text file, comma separated value text document. And then PRECiV has the ability to have an add-in for report generation. Reports would create custom templates where we would bring both the image and the measurement into a predefined template. And these are just Excel or Word document templates or PowerPoint templates. And this would put the image calibrated into your template with the measurements below, your logo, or any specific formatting you want in the template. And that's kind of what this report tab is here at the bottom too. You can jump right to Word, Excel, or PowerPoint and utilize those templates. Okay, so now, as they move through this, if they wanted to do some advanced material solution imaging, I'll click on this tab and it'll kind of show my demonstration unit here has all of our material solutions listed in it that are optional here. This entire list, each one is an optional solution. We don't want to sell the software completely bloated and high cost with every solution in it. So we let the application that the customer is requiring determine which solutions might be needed. If they're only doing grains analysis, they would get the grains analysis solution. If they're looking for particle distribution or phase, they might get both of those solutions to complement each other. Some things, they're looking at metals, they might need cast iron and inclusion. So you'll see a lot of applications that require a couple solution modules. Today, I'm going to kind of show off one of these solution modules. I have a pre-captured image here, some grains, pretty basic, and I'll show off grains intercept. All of the solution modules, they change the user interface now, and they all work the same way. So you have guided instructions here at the top that walk the operator through what to do at each step. And you have at the bottom here, all the steps that it's going to take through this solution, image source, sample information, settings, adjustments, and creating results at the end. This first step is how you capture the image. We could go and capture a brand new live image. We could use the selected images that we have in the gallery here. My grains one is selected currently. Or I could point to a folder, and maybe in this folder I have 10 of these images pre-saved. 5 of them are from sample A that I took the images from, then 5 of them are from sample B that I took images from. What's great about all of the solution modules is they can batch process. And they batch process based on samples. So the first 5 from sample A, I could batch process and get all the results and the average results from all of the first 5. And then I would get the same thing for this sample number 2, batch process. If you have a motorized stage system, you can even set up to use stage path functions. This allows you to have a bunch of predefined points of inspection that you would drive to automatically, do things like autofocus, take the picture, and then process them through the solution modules. To make things even easier, different sample types might require different settings. And right at the beginning, you can load those settings from a file. So the main operator might go through and adjust all the settings for that sample type. And then the operators would just load them from a file by selecting this and picking the sample type they're using. This makes it easy that you're always using the same kind of settings for each sample. You get repeated measurements and repeatable results between operators as well. All right. Down at the bottom is the navigation as they move through the solution module. So we'll just hit next. This is where you put in your sample ID information. You can put in a title here for your group information, and you can put in comments for this first sample. So these are the sample comment fields. And down at the bottom, it says image 1 of 1 because I only have one image selected today, but if you did a batch, it would be image 1 of 10, something like that. So this is the image comment field for each image that comes in. What's great about all these fields is they get saved in the end and they're put in the workbook or the report template that you create at the end. User hits next, they might select the sample type. Again, these are the settings that get loaded in. So if you already loaded in the settings for, your basic bright on dark grains, it's going to automatically select this. They shouldn't even have to make a check here. These settings here, like how you define the grain boundary widths and how noisy or smooth it is, are again settings that get preloaded in if you load it from a file. The user can adjust these if they need to, but it's better to probably load from a file so you have repeated measurements. I know it's a little hard to see, so I'm going to digitally zoom in here with the scroll wheel on my mouse, and you'll see how it's identifying grain boundaries as it crosses over the pattern. And that's what it's looking to detect across this entire pattern. You can make the adjustments here. You can also select what standard you want it to adhere to. The most common one for grains in the Americas is the ASTM E112. When the user hits next, they would get their results. This is showing us a grain size number of 9. It also shows us the number of intercepts that it counted across the pattern and the intercept lengths. The user does have the ability here to delete intercepts or add intercepts. So if there was a big scratch on the surface, they might have to delete some intercepts for that if a pattern crossed over that scratch. So they don't have to reject that whole image. They'll still get valuable data. That's what's allowable here. Or if you have a really hard sample like grains in copper that have twinning lines, if the twinning lines cover any of the pattern, they can delete those out very quickly here to still get accurate grain sizing on copper. There is a reject image button. This is for that batch processing. If one of the images out of the 10 that we were batching had a major issue or it was way out of focus for some reason, you could reject it and continue moving on through the batch. Once you're all done, it's really just getting the results. And here's that Save Settings button. So these adjustments that I made to the settings, if I made any, I could save them now, give it a name for the sample, and then that's a file I could load at the beginning. I'm going to generate a workbook. I'm not going to actually create the report templates today or anything. I'll just do the workbook output here. And when it's all done, the workbook shows all of the measurement information. Again, all the comment fields and titles that I put in are listed here. And then there's a sample page. I only had one image, but if there was 10 images, it would show them here. And we have the image comments that we put into the samples as we went. Again, these workbooks can be exported right to Excel or text files right from the software, or to a report if you wanted to have the image with the pattern on it with the workbook, it can go out to reports. Okay. So the next thing I wanted to show requires me changing out the sample. There are a whole host of custom software solutions. So Evident has a great custom software team that allows us to capture very specific needs from customers or very specific standards that we don't offer in our standard material solutions. Some of these are already pre-done, like you see in the list here. We have a lot of custom solutions that are already pre-made. Today, I want to show off the Navigate on Wafer solution module. What's great about the custom solutions, we can have them built from scratch. specifically for a customer's need and workflow, or we can, take one of the ones that they've already done and modify it to tweak to the needs. If it's just small adjustments, things like, maybe they want a different way they're doing the image format, or maybe they want a different output rendering of the data into a different text document type. So that can be done through our custom software development group. Okay, so now it looks like I got my wafer on. I'm going to start my live image up again here. And bring it into focus. This wafer doesn't have any real unique patterns. It's a demo wafer. I can't show anything with real circuits on it, but it's got some dots and patterning on it. And I created the navigate on wafer based on this wafer pattern. So I'll open the solution module. Again, it's going to have a custom interface. These interfaces that you see now can be modified with the custom software development team. So if there's a specific workflow or button that they need to have in here, it can be added. But the way that this works with the navigate on wafer is we have to set up 3 points of alignment. So I just put my wafer on a wafer holder on the stage. It wasn't perfectly centered or perfectly rotationally aligned. You can see I'm not perfectly straight. I'm not too worried about that because I have to set up these 3 points to define the location of the wafer on the stage. I already have the saved definition, but if I needed to, I could load the file of all my defined wafer points and chip lists. So this is a file that has been saved and I load it in. I have just a few chips, 4 chips predefined. Normally this would be hundreds of chips on a wafer, but for making this quick for the demo today, I just defined 4 chips. And I'll move to point 1. So this is going to automatically move the stage to the general area of where my alignment point should be, because I put my wafer back on a holder, so it kind of places it in the general point, but it didn't put it perfectly centered for me. So I'm going to tune these up a little bit or align them even more. All I have to do is click on this point, and that's going to center it for me. And this is the point I defined this wafer as an alignment point, my first set point. So I'll set point 1. I might move down to point number 2, and I'll touch it up. And the 2 bottom points go along a horizontal axis. So these will correct for our slight rotation variance here as well. So I'll set this as point 2. Then I'll move to point 3. And it's going to drive over to the last point. Center that point up. And now that I have all 3 points marked, the operator really could just hit the start scan button. It's as simple as that. And it's going to go through a routine, moving to each chip and taking multiple pictures inside of that chip. This can even be customized as much as moving to that chip, change to a higher mag, and take the different pictures within the chip. So first thing we did is had defined all of our chip. I can double click on a specific chip and it'll move to that chip location. And this is exactly that chip location starting point. And what I have for each chip location, I only just did 2. It's going to take 2 pictures. So there's 2 points of interest in each chip location. And it's just going to quickly move to all 4 chips and take 2 pictures of 2 locations for each chip. Very simple for this demonstration. I wanted it to be quick. So once you have that defined, again, there's multiple points where you can hit the start scanning here. I wanted to also point out that you can set up an image array. I didn't think about mentioning this right at the beginning, but I have it just driving to 2 individual points, single frames they call it. But we could have it drive at higher mag within a chip and do a stitch or an array. 2 by 2 frames, it'll stitch those together, what we call multiple image alignment. And if you set that up, it'd move to chip number 1, do that stitch, 2 by 2, 3 by 3, whatever it takes to cover the area that you want to capture, and then move to the next area and do the next array. And then move to the next chip. It might have 2 or 3 arrays within that chip. That can all be set up here as well within your scans. And then you have the ability for saving options if you want the images saved out at high full resolution TIFF images or JPEG images. When the operator hits start scan, it's going to have them select a save to location. If there's old data in there, like I have here, it's going to even warn me, are you sure you want to discard the previous contents? It's going to delete it if I hit yes and start capturing all new images for us. When I hit yes here, it's going to go kind of fast, and I hope that the webinar shows the speed here, but it's going to move to position 1, capture 2 pictures. Now it's moving to chip 2, and it'll capture 2 pictures. And chip 3, capture 2 pictures. And we have quite a bit of distance between these chip locations. So now that it's done, and I have those locations all captured, it's automatically saved them into the location that I was saving to on the data drive. I'm going to go ahead and open that location here in the software. And we have chip 1 through 4. I had 4 chips. And in chip 1, I have 2 pictures. And in chip 2, I have 2 pictures. Notice the pattern should be matching. They're going to, because it's a repetitive pattern over the wafer. And at any point, I can review these by opening them in the software. By double-clicking, I can open them. I can see on this first location, the reason why I picked one of these points is I had a nice little defect on this spot here. And in chip number 2, it even had a big blob spot in the pattern here. So this could be the review that the operator does after the effect. One thing to mention is we do have desktop licenses of the software. So if they wanted to do all the image capturing in the tool, in the fab, suited up or something like that, but they don't want to review all these pictures, they could use desktop license software back at the office on the laptop and navigate to where these images were saved to the network location and review them after the effect and still take measurements on them. They're fully calibrated images. Okay. And to exit out of the solution, it's just this X button at the bottom. And again, that was the Navigate on Wafer custom solution. You can see there's quite a few different ones that we have default custom solutions, and then we make custom ones very specific for each customers out there as we go sometimes. That was kind of the end of my presentation, Dirk. I know it might have went faster than we thought even.
Yeah, nope, that's fine. We do have a few questions here, and but before we do those questions,
Yeah.
I do have a poll I need to put up. For those of you who need a certificate of attendance, please answer that poll. You don't have to worry about it. If you don't need a certificate of attendance, you can just ignore that. Okay. Oh, and if you do have further questions, there is a Q&A button towards the bottom of your screen. You can just mouse down there and ask your questions. So let's get to them. Oh, calibration. How do you calibrate your equipment?
Great question. Yeah, so the PRECiV software has multiple calibration tools. Specifically, the calibration of each objective is done through, pixel to micron measurements. So it has, the original way we've calibrated software for years by putting a standard on the microscope. The standard has a known distance, and you go to the specific objective or zoom value, and a user marks the distance and then tells the software that distance is X, if it's 100 microns or 50 microns, whatever it is. And then the software would calibrate the pixels per micron. And that's done through device calibrations here. I'll load this window up so you can see there's a lot of other calibrations that get done besides just the manual magnification calibrations. There's stage calibrations, there's camera calibrations, there's something called shading correction. When you have some more of the advanced functions like motorized stage, you get things like camera to stage rotation calibration gets done as well. So this is typically done during the installation by the evidence support team when they set up the microscope for you. But the manual magnification calibration has a second way in here as well. If they purchase the standard that works with the software from us, there's a calibration standard with known distances, and it can do auto calibration. Auto calibration would work for every zoom setting and every mag objective. It would go through and it looks at the pattern of lines that it knows that distance of the pattern. So it measures them across the entire field of view. which increases accuracy for your micron per pixel calibration values than just one point to point that a user does manually, if that makes sense. So the auto calibration uses contrast-based detection of the lines on a very specific standard type. And it has that capability as well.
Okay. And you had mentioned, I think you mentioned this earlier, Z measurements, but can you go over the Z measurement capabilities?
Absolutely. So yeah, 3D measurements. I'll go back to my 3D image here. So since we capture something with a motorized or encoded focus, it has to have that to capture the height data as it builds the all-in-focused image. We call it extended focal imaging. Then it has a layer on the image called height layer. You can actually show the height layer here. So this is the height layer based on intensity of pixels as they came into focus. And when you have that information, you can then place your profile lines on the image, and you can see across the profile line the height data rendered, or you can render the 3D image as well. But with the profile line measurements, we can just mark points on the profile. If I wanted to do it over here, I can mark a point on one edge and then move to another point and get a height measurement that way, going from high to low. So it's going to be a negative value. You can also measure just the widths between points if you wanted that information. You can also use some of the advanced 3D measurement tools where I want to expand them out here. Bear with me one second. Simple 3D, so where you can place on auxiliary tools where it finds the maximum height point. So say you don't know, I'm gonna actually delete this one out real quick. Let me click on this. I'm gonna delete out these measurements now, clear out the screen. So if you didn't know where the highest or lowest point was in a region, but you wanted to use those as anchor points to place your profile line, you can use this maximum height and draw a box over the area of interest, and it's going to find the maximum height point in that area. And it's going to be a little hard to see, but it's probably really hard to see on the webinar, but there's a little point right here. It shows the maximum highest, the highest point on that sample. And then you can do the same thing for the lowest point somewhere in the valley area. So if I did something like that, I would have the lowest point. Now I can use these link object function to come back and plot my 3D profile if I wanted to. So if I did an arbitrary one, I could use that point. You see how it kind of highlights when I mouse over it? All the little white crosses come up. Those are the anchor points that I can link to. And this point in the middle of the field was the lowest point that it found in that region of interest. So I can select it. And then when I come over to this one, I can select this point on the edge here, which was the highest point. So you can do things like that to put the line profile right across your highest and lowest points within a regions of interest. There's a lot of built-in tools like that for 3D rendering. And once we have that, we can come down and you can take measurements of any of these points that you want. Maybe I want to go there to there. That point all the way over to that point, measuring a height difference. And the 3D profiles can be exported out as graphs. You can also export the raw height measurement data that you get here to text or Excel documents. Hopefully that answered that question well enough.
Yeah. This next one, I think, has to do with the measurement volume, and I'm going to assume of the microscope. Nesta wants to know, I need to measure a piece 1.5 inches by 2.25 inches by 0.25 thickness. What's the range of this device?
So again, PRECiV is the analytical software we use on a lot of different microscopes in the industrial microscope range. So if you're looking at very large samples, very bulk samples, you might utilize PRECiV on something that's very low mag, like our stereo microscopes, like our SGX 7 or 10 models. And that would give you a very large field of view, low magnification capability to take dimensional measurements on. What I'm using today is our digital microscope, and it also has the ability to do very low magnification ranges. You can see this image here. If I go over here, this image here is at a very pretty low mag using a 3x objective. It's not our lowest mag, but the 3x objective has a field of view of 10 millimeters in width, 6 millimeters in height at the lowest zoom. So that's kind of the field of view just in one single frame. Now, since it's a digital microscope and it has the automation part to it, we could easily increase our field of view by using the panorama tool where we stitch together large areas. So this might be stitching together fields of view that are, if you need 3 of these, 3 times that fields of view, you might have a 3x3 array, something like that. And this is where the operator can just literally say, move to the top left corner and the bottom right corner. They define that, and then they hit start, and it'll stitch it all together for them.
Yeah, for those of you who aren't familiar with the stitching Rob's talking about, that's just the ability to take a small field of view, but add them all together. It's just like you said, stitch them across. So the microscope moves, takes a picture, moves, takes a picture, essentially, and then puts it all together in one big picture. So even though you have a small field of view, you can capture all the entire moving range of the microscope, right?
That's correct. And sometimes that's nice because you might want to use a little higher magnification to gain, more detail, higher resolution by changing to a higher magnification in some cases. So you can utilize the XY stitching, and then this system also has motorized focus, so you can do the mix EFI and 3D at once. So you can capture all the height data across all the stitched frames. And then you can take measurements over that whole area, both in X and Y, and your profile lines for 3D measurements.
Okay. Does PRECiV have any weld joint integrity or penetration type measurements?
It does. In the advanced measurement tools, that's a great question. It does have the weld measurements. So you can see them here. We have throat thickness measurements. This is part of the advanced measurement add-in solution to, it comes part of the PRECiV DSX software. The other packages, PRECiV Pro has it, PRECiV Core is our lower package. So we have different levels of the software, different packages that we offer for different application needs. So weld measurement is in the advanced measurement tools. We have throat thickness, we have asymmetry lines, and we have multiple perpendicular lines. These are used for measuring cross-sectional welds and like the thickness or the throat thickness of a weld. And it takes multiple points of measurements and gives you a very accurate throat thickness measurement or penetration depth measurement.
This is more kind of medical device oriented. Is the software certified? Like 21 CFR 820 or ISO 13485, that sort of thing.
Another great question. Yeah, it is not like CFR Part 21 or CFR 21 Part 11 certified.
Part 11, yeah.
A lot of the certification that it does have is for the industrial material solutions. Most of these solutions have their own standard that they are certified to, for like we're using ASTM standards or certain ISO standards. A lot of them are built into the material solutions. So in that case, yes, but the specific CFR one, no, it's not. I've had a customer meet some of the demands of the CFR by being able to export measurements directly to the text documents and stuff, where they have them automatically import into their secure data base system and stuff like that. But the software in general doesn't, because the measurements can still be selected and deleted, and that's the main no they don't want.
You had mentioned earlier that the PRECiV is universal. The software is being intended to be used across all sorts of Olympus models. Can it be used with third-party instruments as well? Not Olympus, not Evident?
Yeah, another great question. So if you were to connect to even a legacy Olympus product that might have been old enough that it doesn't have connection capability to a PC, like our new ones have simple USB connections in most cases, even then it can connect to either third party or older systems, legacy systems. You just won't have some of the controls. They'll be more manual in the software. Like right now I'm connected so I can turn the light up and down, but obviously on a manual system, you'd have a knob on the microscope to turn the light up and down. You would still have the ability to create your observation modes. So you would tell the software when you're creating a manual microscope what observation mode you might have. If that microscope has bright field and dark field, maybe it has DIC, you'd set those observation modes up. Just it won't switch to them automatically when you select them, but it does apply some settings. Things like shading correction could get applied based on the observation mode that you're in, which is great. But with our camera connection on any microscope, even a third party microscope, we can calibrate still. We can tell it which objectives it has in the configuration and go through the calibration process and still use any microscope out there with the software, as long as it has a camera connection. So,
you were just mentioning calibration again. We've had a whole bunch of calibration questions here, basically oriented around, is there a recommended calibration frequency, verification, that sort of stuff?
Sure. So calibration frequency is very determined by maybe a standard that you're adhering to or an internal scope of work document or procedure internally. Most customers have their own internal requirements for calibration verification check frequency. You're not going to actually recalibrate the microscope, because the only time the microscope calibration would change is if you physically move the microscope, and it could cause calibration to vary because you've moved it, or you've damaged an objective or something like that. Or if they disconnect components on the microscope, if they change out the objectives or something, then they'd have to redo calibration. But what the frequency they're talking about is check calibration. So that's just done with your measurements. You can put on a verified standard and do a calibration verification at any point. If you take the next level and get a certified calibration standard and everything like that, certain systems that we offer have calibration certificates that can come with our service engineering team that do traceable calibrations, they call it, to very certified standards. That can be done in this certain software on certain systems that we offer, like the digital microscope or laser scanning or measuring microscope, the STM7. They have the ability to have certified traceable calibration. But again, verification of the calibration, a check, that might be done weekly. I have some customers that do it daily. They put on a known standard and they take they're trained to do certain points of measurements on that standard using the software. And it's great using the detect edges because it improves the accuracy, and they verify their calibration as often as needed. Some customers require it yearly. So it's an internal requirement in most cases.
Talk about programming multiple steps in the software. I'm assuming this means if you're setting up a guided inspection, I guess.
Something like that, yeah. So if you have, an inspection where it captures images and you are, each time you capture, you have to go in and process it a little bit. Maybe you have to apply a certain filter to enhance that image. Maybe you have to apply a separate filter to separate particles a little better. And maybe you adjust the contrast. So if you have multiple steps that you're doing after an image acquisition, you could use the built-in macro tool. The macro tool up here allows you to capture those steps and apply the macro to the image. You can apply macros to single images. The macro can do everything from turn on a live image, prompt the user to switch to a certain mag, take that picture, apply the contrast enhancement, apply the separate objects filter, and then trigger the particle counting if they have that feature in the software to do particle counting. So that macro can be ran with a single button click to simplify your steps. Macros can also batch process in our PRECiV software. So if you had the system take 20 pictures and they were saved to a specific location, you would point the macro to that folder. It would detect the 10 images and it would apply the process of those steps to those 10 images that are pre-saved in a folder. And going as far as exporting your measurements out can be saved through the macro step as well. So that's all part of here in the PRECiV Core and Pro and PRECiV DSX software versions have the macro capabilities up here.
Okay. Let's see. Images and measurements able to be exported. I think you talked about exporting. I know. I think kind of a related question. I'm assuming that the reports can be that you have canned reports there, kind of standard formatting for reports. Can those be modified, to
the templates
your
themselves?
own kind of internal needs?
Yeah, let me see if I can. Bear with me a second. Sometimes I can get. It's just not going to work on this right now. I can't quite show the report template, but they are just standard Word or Excel or PowerPoint report templates. Maybe it'll let me go.
Oh, so you create a template like Word and you're able to bring it up or whatever.
Yeah, so you have something called a document template, and will it let me open the folder here, edit? Oh, down here. I'll just go to it and open it directly. Maybe. There we go. It doesn't want to let me do it on here, but I'm going to do it this way. Bear with me. So you can take this document template, this is the Word one, and it will allow you to open it in Microsoft Word. Yeah, it keeps digging on me. It's not going to let me open it directly, but they're as simple as opening it in Microsoft Word, and you can change the header or footer if you wanted to put in your logo and stuff like that. And then our software also works with page templates. Page templates do things like if you have 2 pictures you want inside the document template, you can create your own custom page template here. And you can even point it to a new folder where you have your own custom page template saved. And here we go. Let's see. Let me go here. I'm just going to open the document template folder for me. Here we go. Now maybe I can actually open the document template in Word. There it goes. So here's.
You probably have it on the other. You probably have it on your other screen there.
That's true. Let me minimize.
Yes, we're seeing it. You might be able to drag it over.
There we go. So this is just the document template with our
logo
in it. It's pretty simple, but you can even open the page template. So if you had like 2 images and a portrait, this would be the page template. What's great about the templates and the report, using a report template, is it'll bring the image in calibrated. It sizes it properly based on how you have this page template defined, but it can also be customized. You can modify this to load in a whole lot of values automatically from that image. Things like the name of the image that you saved it as, but the date that it was taken, the magnification that it was taken at, the resolution, everything, even the exposure time of the camera can be a field that you type in down here and save it as part of your template. And as soon as the image is loaded in, it pre-populates all those fields underneath of it. So it can pre-populate all the information for you. That's cool. The benefit of using the templates, and they're as simple as modifying them in Microsoft Word or Excel, or we even have the PowerPoint templates.
Well, we have reached the end of our time here. Rob, thanks. Nice presentation on the PRECiV software. Good stuff.
Really appreciate the time to showing it off, and if you get more questions and stuff like that, we'll help answering them after this as well.
Yeah, so that was going to be my kind of leads right into what I was going to say here. So you'll be getting an email, all of you, within about 24 hours. That'll have a link to a recording of the webinar as well as, I believe, a PDF of the slides. And there will be a return address on that. So if you have further questions for Rob, you can just respond to that. You can just respond to that email, and we'll make sure that we forward on any other questions to Rob and the folks at Evidence so that you can get the rest of your questions answered. And that will be it. So keep your eyes open for, keep your eyes open for that email with a link to the recording. And that is it for today. So from all of us here at Quality Digest and Evident, Rob, appreciate your time. And thanks
Thank you.
all for joining us.